All right, let's begin lesson 1-7. This is representing functions as rules and tables. And we'll talk a little bit about that messy title. But let's first of all talk about what a function is. Okay, a function is, it consists of a domain, and a domain is your set containing numbers called inputs. Those are your x values. So when you hear the x values or x, that is also your domain. Okay, the range is a set containing numbers called outputs, or your y values. Okay, when you hear the y values, those are all of that's your range. They will make up your range. Okay, your range is dependent upon your domain. In other words, your y values are dependent upon your x in a function. What you put into the function for x, what number you put in, determines the number that you get out, or an output, or your y. So you put a number into the function, and you solve the function, and then you get the y value. You get what it equals. A function has a pairing of inputs with outputs, such that each input, or x, is paired with exactly one and only one output y. Now, this is not in your notes, and we will talk more about this later. But if you put an x into a function or into an equation and it generates two different y answers, it is not a function. Okay? And we'll explain that in a minute. I have a very simple way for you to identify that. In an ordered pair, it would be domain and range. So your domain looks like this. If I could get my ink to work. Okay? The x, y, just like an ordered pair when you graph. Okay? Your x is considered your domain value. Your y is considered your range value in that ordered pair. All right, so let's get started of identifying domain and range. This is fairly simple. Okay? The input-output table shows the costs of various amounts of regular unleaded gas from the same pump. Identify the domain and range of the function. Okay? Well, I will help you occasionally. Sometimes you have to think of it this way. If you don't have the actual x and y identified, you have to ask yourself, which value in this table is dependent upon the other value. Okay? Your cost of gas depends upon how many gallons you buy. So my dependent value is always going to be my y. So since my cost depends on how much I buy, it would be my y, and the gallons I buy determine how much my cost is, so it's my x. So therefore, your domain is your set of your inputs, which it tells you right there, but I'm wanting you to also think it through. 10, 12, 13, 17. That would be my domain or my x values. My output, right here, would be my y values. $19.99, $23.99, and so on. So the domain is my inputs, the range is my outputs. So let's practice this. Very simple. Identify the domain and range of this function. Okay? So hopefully you've paused the video and you are identifying these. All right, your domain was 0, 1, 2, and 4. Now notice your range has 4 values, 1, 2, 3, 4 values, but we've only listed 3 down here. That would be because we don't have to list the 2 twice. Okay? This is still a function because every x value has only one y value partnered with it. Okay? The 0 doesn't have 0, 5 and 0, 2. It just has one value partnered, so it's a function. But we only have to list the 3 ranges because we don't have to list the 2 twice. Okay? All right. Example 2. Identify a function. This is where we're going to determine if it is a function, if we have those repeated values. So tell whether the pairing is a function. Okay? Here we go. For letter A, here is our input, 0, 5, 10. Okay? And here is our output. Okay, there's a couple of ways we can identify that this pairing is not a function. A couple of things that are key. First of all, we have 3 input values, but we have 4 outputs. You should never have more outputs than inputs. definitely not going to be a function in that case. Okay? Each x value should only generate one y value. Okay? The other reason we can say is this, it is not a function because the input 0 is paired with both 2 and 3. We can't have a 0, 2 point and a 0, 3 point and it be considered a function. Okay? All right, let's do some guided practice on this one. So pause the video. You attempt to determine whether each input-output pairing is a function. Okay, number 2, let's look at it. 3, 6, 9, 12. So we have 4 inputs and we have 4 outputs. We don't have duplicate or 2 outputs for any one input. So it is a function. Okay, so this next one, tell whether it's a function. Okay, again, if we listed our inputs over here, we would have 2, 4, 7. So we would have 3 inputs. And our outputs, we would have 0, 1, 2, 3. So we would have 3 inputs and 4 outputs. We can't have that. You guys, the easiest way when you do a table, when you're looking at a table, is if there is a repeated x value with 2 different y values, it's not a function. Okay? If you see a repeated input with 2 different outputs, cannot be a function. So the key is this right here, looking for those repeated inputs. All right, moving on. Making a table. This is relatively easy, and I'm going to show you how to do this. The domain of the function. Now here is what we are considering a function. This right here is our function. Okay? There's our function. Y equals 2 times x. And here is our domain. And they want us to make a table and then find the range of the function. So this is what we're going to do. I believe your notes have your table up and down. This PowerPoint that was created, they make the tables across. I prefer to have a table that looks like this. So I tried to make yours in your notes like this. Okay? So there's your function, y equals 2x. They gave us the domain of 0, 2, 5, 7, and 8. And all you do is simply plug in each value of x and find the values of y. So for example, when x is 0, 2 times 0, right here, because this is our function, the function is y equals 2x. 2 times 0 is 0. So when x is 0, y is also 0. Okay? I'm going to do these in a different color. Okay. When x is 2, we plug that in. 2 times 2 is 4. When x is 5, we plug that in. 2 times 5 is 10. 7 times 2 is 14. And 8 times 2 is 16. So now I want you to look. First of all, we see a pattern that the y is twice the amount of the x. So there's a pattern there. And we'll just look for patterns because we're going to take tables and make rules later. So what's the domain for this function? The domain is always your x values. And they are always listed from least to greatest. So on your domain notes, I think it's on here. I should probably just print it. There we go. Oh, they've given us the domain. Sorry, 0, 2, 5, 7, 8. The range of the function is 0, 4, 10, 14, 16. That would be our range. So domain x, range y. All right, now they're going to give us the inputs or the x values and the y values, and they want us to figure out what the function is or what the function rule is. In other words, they want us to say y equals what? What are we doing to the x's to get the y's? So let's look at what they're doing. So we're going to consider x as the input or the independent variable and let y be the output or dependent variable. So we notice when we look at some of the patterns, we want to look for patterns in those numbers. And we notice that our x and our y right here is 0, 2. So and then here 1, 3, 4, 6, 6, 8, 10, 12. So we do notice that each output is 2 more than the corresponding input. Okay, and there we say that 2 more than, right there. That is some of those words we looked at earlier in the chapter when we were writing expressions and equations. 2 more than the corresponding input. So a rule for the function is y equals our input plus 2, or x plus 2. So we could look at it like this. Y equals the input plus 2. And our input is our x value. So 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6, 6 plus 2 is 8, etc. Okay. All right, example 5. Loving this, right? Writing a function rule for real-world situations. Always good. Okay, you are buying concert tickets that cost $15 each. Okay, underline this because this is important information. We know we're probably going to be using that. Okay, you can buy up to 6 tickets. You can't buy more than 6. Okay, write the amount in dollars you spend as a function of the number of tickets you buy. And then identify the independent and dependent variables. And then we're going to identify the domain and range of the function. All right, so we have a couple of things we have to do. We have to write the amount that we spend as a function. So to write a function, determine what's independent and dependent, and then identify domain and range. So here we go. So of course we're going to write a verbal model. It always helps to write a verbal model, and then we can write the rule based on the verbal model. Okay, so let N represent the number of tickets purchased, and A represent the amount spent in dollars. So amount spent, however much you spend, is going to depend on the cost per ticket, obviously, times the number of tickets you buy. I mean, if you buy no tickets, you're going to spend no money. So however many tickets you buy, that determines your cost. Okay, so that being said, our cost, or our amount in dollars, is A equals the cost per ticket, 15, times the number of tickets purchased, N. So our formula, our function is A equals 15N. Okay? All right. Now, there's our function rule. And think about this. The amount you spend depends on the number of tickets you buy. Okay? So N is your independent, and A is your dependent. Okay? Now let's actually write the function rule and make a table. So we have our function rule, A equals 15N, and since we can buy up to 6 tickets, the domain is the numbers 0 through 6. We can buy anywhere from no tickets to 6 tickets. So that will determine the different amounts of money that we can spend. So here we go. Number of tickets N is the X, or the independent, and the amount in dollars is the Y, or the dependent. So here is our table. 0 tickets obviously would cost $0. Now, let's identify the range. We've already gotten the domain, so now we can identify the range. And the range is just the Y values. 0, 15, 30, 45, 60, 75, and 90. Okay? Hopefully that makes some sense to you. Again, if not, rewind, rewatch, also write down your questions. Okay? All right, so let's do some guided practice. You can pause the video, and I want you to try these 2 guided practice problems. We're going to make a table and identify the range. Pretty easy stuff. Okay, first one, our range should be 5, 7, 10, 13, and 24. When you plug in each of these numbers for your X values, you should get these answers for your Y values or your range. Okay, last guided practice problem. Write a rule for the function. Identify the domain and the range. Okay, so we're going to write a rule. Let's think about this. Time in hours, pay in dollars. So pause the video and think about writing a rule for the function and identifying the domain and range. Okay, well, which one would be the independent or the domain, and which one will be the range or the dependent. So how much pay you make depends upon how many hours you work. So this is my dependent or my y, and this is my independent or my x. Okay? So now let's look at the values. Hopefully you figured this out. We have our x is 1. In 1 hour, we make how much money? $8. In 2 hours, we make $16. In 3 hours, we make $24. Do we see how much we are making for each hour? So hopefully you wrote that your pay, if you wrote a verbal model, equals time spent, or hours, time times hourly pay. There's a verbal model right there. Okay, so our time is in X, and we figured out our hourly pay was how much we're making per hour. So there we go. So Y equals, and notice how I said we cannot have a variable first. We have our number first, $8 in an hour times the number of hours that we work. Hour or time. Okay? So our domain is obviously 1, 2, 3, and 4. Our range is 8, 16, 24, 32. There's our function rule and our domain and our range. Okay? There is no, obviously, daily homework quiz, so you can stop the video, bring your notes and your questions to class, and a smile. Thanks.